Finding the Jacobian matrix of a vector function which has trig in it. Pretty straightforward, except for now we're going to be differentiating using the product rule, and it's going to have sin h and cosh in it. So what is the Jacobian matrix? So it would be jxy, which would be the df over dx, df dy, dg dx, dg dy. That there is the Jacobian matrix. What is f and g? F is this, g is this. You could put p, q, r, it doesn't really matter. It's just an arbitrary value that you're assigning so you can keep track of everything that you're doing. So let's do df over dx first. You need to know how to do partial derivatives. I've got another video on that, so you can go check that out. I'll put the link in the description for it. You'll also need to know how to do the product rule and chain rule for this. Both videos are also linked in the description. So df dx would be dxy squared sine h x squared y. Let's do df dy. Df dy, we now have two y parts, so we would use the product rule, and df dy would be x squared y sine h x squared y plus cosh x squared y. We can now do dg dx. Again, we'd need to use the product rule because we've got an x here and then a bunch of other things with x. You'd also use the chain rule inside the sin h, so that's going to be xy squared cosh xy squared plus sin h xy squared. And then finally, let's do dg dy. A bit more straightforward because there's only one y term. We're holding the x terms constant, and you're going to have 2x squared y cosh xy squared. You need to know how to do partial derivatives. This video isn't about partial derivatives, but I've got multiple videos on my channel, so please check them out if you are confused with how any of these are done. Nice and easy final part now. We've done all the hard work, we've done all the partial derivatives, so now we're going to put it into the matrix. So we would get df dx, go here, so you're going to get 2xy squared sine h x squared y, df dy, which is here, you're going to get x squared y sine h x squared y plus cosh x squared y. Then we have dg dx, which is going to be xy squared cosh xy squared plus sin h xy squared. And then finally dg dy, which we're going to put here, which is 2x squared y cosh xy squared. And this is all a big matrix. The next steps would be you could find out what the determinant is, or if it was about a point, you would plug it in and you would be able to get the values for it. But at the moment, for now, we found the Jacobian matrix of the vector function, and that would be your solution.